Let's now see the architecture of this microcontroller and pin of the microcontroller. And we say also see the various pin, that is crystal pins, VCC ground pin, and some of the port pin. That is sorry, AVA pin and PSN part. Now see what is the port pins. So these are the port pins. So it's a family 4 ports. Each port is having 8-bit wide. So it's putting 8 pins. So these are the pin numbers, and these are pins. Normally these pins are named like P0.x. So P0 means port 0, X means 0 to 7. So P1.x means port 1 and pin number X. So X may be 0 to 7. Here these pins are 0 to 7, and each pin is 8-bit wide. So these pins are bidirectionals, so it can be towards the input as well as output. Now, so what is the need of these pins? So to connect the external word, to communicate with the CPU, it contains what is the inside the pin. So pin is having a D latch. So D latch is controlled by write to latch, and to write the latch, if it is 1, write the data to the D latch. It also contains two tri-state buffer. So tri-state buffer 1, it is controlled by read pin, and tri-state buffer 2, it is controlled by read latch. So these are the two buffers. And similarly, it is having a transistor. So NMOS transistor is connected. So gate is 0, it is open, and gate is 1, it is a closed switch. Now, so this is basic things to go this internal structure of this pin. See, this is the port 1. So port 1 is so this is D latch. So these are the tri-state buffers 1 and 2. So it is controlled by read pin, it is controlled by read latch. So this is transistor connected to the Q bar pin of this D latch. And suppose as already stated that this is port 1, so it is a port 1.0 or port 1 maybe, and this is the load register which is internally connected. So this is our pull-up resistance. So here right latch, it is correspond to the clock signal, data is available. Now see, suppose I want to writing 1 to the output port. What happens? So writing 1 to the output port. So 1 to writing port 1 to the pin. So to connect pin. So this is the 1 input. So output it is 1 is available. So its complement available at Q0 pin. So once Q0 pin connected, so transistor M1 will not be switch on. So it is a switch off. So the data which is available here, so it become connected to the VCC. So that is 1, that is VCC available at this port. So write the 1. So 1 is available here because this is deactivated. So transistor, so deactivated means transistor will not work. So writing 1 input, so we'll get output 1. So output pin is 1. Now how to write 0? So that means we require 0 at this pin. Now for this purpose we require a 0 here. So write to 0 pin. So this is one step. So 0 is available at Q0 pin, Q pin. So its complement is our Q bar pin. So transistor is conduct. So it becomes short circuit. So it connected to the ground. So that means this ground potential is available at P0. So this is our 0 output. So writing 0 is through this port 1.0. Similarly, reading, how to read the port. Suppose I want to read the high at the pin input. So high. So how this high is read through the microcontroller. Now for this purpose we have to make this pin command like move pin move P1 comma #0F. So we have to read it. so that means it is input port. So it is 1, so 1 is available, so 0 is available, so transistor will not conduct, so this will not conduct. So at the same time, so due to this external pin is high, due to this command external pin is high, that means this is high, and so 1 is available to this buffer, and it processes inside the chip. So we can read this port. When we make this D input is 1, and this is available due to this command move a comma p1. Similarly, how to read the low input. So for this purpose, we have to make pin 1, and so it becomes 0, and to the external command, so this pin is low, and this low is available here. So every time we have to make this pin port as an input port. So through input port we can read the port easily. So output 0 is available through the transmit buffer to the D input, and similarly it goes to the internal CPU bus. So in this way we can read and write the input these ports. So this is available for port 1. Similarly, other pins are P2, 3. So these are having internal pull-up resistor, whereas port 0 doesn't have internal pull-up resistor. So it is need to connect one external resistor at port 0. So it is open collector type of output. So programming is same for all the ports. There is no difference between internal working of this port. So except we require to connect one external resistance, that is pull-up resistor, at port 0. So this is the port 0. So here it is no pull-up resistors. So port 0. So we have to connect such type of external resistors at the pin. So there are some alternative pin functions for port 3. So port 3 is a multiplexer. It can use as I/O as well as transmit receive. Similarly, this is the interrupt. These are timer interrupt, write bar for the external memory. So similarly, these are some registers, and after reset, already we have seen this reset pin. Now once we reset the pin, the program counter becomes 0. Accumulator becomes 0, port B becomes 0. The stack pointer pointing is initial value is 0007, whereas all the ports are 0 except SP, that is stack pointer. So next time we see the internal, that is the instructions of the 8051. Thank you.